last not least, we have Stephen Richardson, who's doing some very interesting work with Sainsbury's on embodied energy, embodied carbon assessment using life cycle assessment methodology. Stephen.
Thanks, John. So, Stephen, working for Sainsbury's. So obviously my project is looking at embodied carbon in this specific context of retail construction. This is one of Sainsbury's most recent stores down in Weymouth. Very sort of high-performing, what we might call an environmental store. In fact, it was one of our 000 stores, so it has zero operational carbon, zero waste, and zero water. And that wasn't really my remit. So if you've got any sort of questions on that, by all means, I can try and answer them. But that's not really what I want to talk to you about now. Just to sort of kind of set things in context. My project, as I've said, is about obviously embodied carbon. That's why we're here today. So I'm going to give you a quick overview of some of the aims of the project, and then dive into one particular issue that I'm sort of looking at and have been thinking about a lot recently. So the broad aims of the project, obviously understanding the issues of embodied carbon within the specific context of retail. So what does a business like Sainsbury's need to understand about this issue? And within that, the measurement of embodied carbon. How do we measure embodied carbon in a way that's appropriate for this context, which is one where we have a rolling program of capital investment. Year on year, there's new stores being built, there's store extensions, there's major refurbishments going on. We want to also reduce embodied carbon, so we're looking for existing opportunities. What's available to us at the moment, and one example of that is around concrete, and that's again something where the sort of academic and industry pieces have linked well. We've been able to look at what the research around low carbon concretes and what's available there. We've done some trials, some actually at that Weymouth store, where we work with a contractor to identify some alternative lower carbon mixes. Looking ahead for the business, we want to be able to actually set reduction targets. The business has its sustainability goals. Some of you may have come across the 20 by 20 plan that Sainsbury's has. That currently sets some challenging targets for carbon reduction, but they're all around operational carbon. So the business kind of recognises that beyond 2020 it needs to start thinking about where we go from there. And we're hoping to be able to include some embodied carbon reduction targets in that next set of goals. And hand in hand with that, we also then need to be able to have tools which will support the designers, the decision makers, to actually drive innovation to be able to then hit those targets. We want targets that are not just tick boxes that we know we can achieve. We want something that's going to stretch us and challenge the business. So that's broadly an overview of the project. As I say, I'm going to kind of dive down into one particular issue which John alluded to, which is interesting, I think, not only because I've been working on it recently, but also because I think it again sort of fits in with the umbrella theme of today's event, which is about how industry and academia can kind of collaborate and complement each other. And that is the issue of service life assumptions. John mentioned the kind of magic 60 years. I hope this graphic is reasonably clear. It's really a repetition of some of the graphs we've seen already today. It shows for a range of types of building a representation of the whole life cycle carbon emissions split between embodied and operational. And it's a nice headline that you'll often see at an event like this or in a publication about embodied carbon, because what it tries to illustrate is that embodied actually is often a bigger chunk of that pie than we might think, and therefore is worthy of our attention. The problem is that it is based on a number of assumptions, and I haven't got time to go into all of them, but one key assumption that I've been looking at is this one about service life, and by that I mean the life of the building. How long is it going to last? When we model the environmental impacts from cradle to grave, we have to make an assumption, particularly for buildings, because they're such a long-lasting product. We have to make an assumption about how long that service life will be. And the challenge is that often this sort of headline data is presented to us without, well, in this case, without even giving us the number. We don't know in this case, without digging into the report, what the assumption was. I think off the top of my head, the report doesn't actually tell you. Interestingly, I may be wrong, but I think that's correct. And this is a problem that we see both on the academic side and on the commercial side. So in academic papers, I'm 18 months into this 4-year project. I've done quite a lot of literature review now, and I've come across very few papers that actually justify why they've chosen the service life length that they've chosen. Some examples there. Again, these are literature review papers. We see a range of different service life assumptions. There's one there with ranges from 30 to 100 years, one with 10 to 100 years. So lots of different assumptions being made. John mentioned the magic 60 years. That seems to be one that a lot of people go for. Actually, Cabiza in their paper seem to think that 50 is the most commonly selected. But the question kind of remains of why. Why have they picked this number? And actually, in a huge majority of cases, they just don't tell us. So that's a problem, and it's also a problem on the commercial side. Sainsbury's has had some studies done of its buildings, and again we see a variety of numbers. We've got some where 30 years was used, we've got some where 60 years was used. Potentially that came from Sainsbury's, but there's no record of that in the report, so there's no way to know why that number was chosen. So this is an issue. It's an issue, from an academic point of view, because we're all about rigor and defendability, but it's also an issue from an industry point of view, because we want to be able to make design decisions based on some of this information. We want to, we're sort of saying, embodied carbon is a big problem, and we're using these headline figures to prove that, but then they're based on assumptions that, aren't being justified properly. So that's kind of the issue that I've been grappling with. And what I thought is that, rather than sort of trying to create a crystal ball and guess into the future about how long a building will last, maybe we should look back into the past at how long our buildings have lasted. And that's effectively what I've done. And there's a challenge here that I'm still sort of trying to get my head around, which is that a lot of our buildings are still standing, they're still being used, so they haven't come to the end of their service life, if you like. And some of those buildings will have been around for potentially 100 years. But what I've done first of all is focus on the buildings where I know they've come to the end of their service life. And this is focused on the context of retail, not just Sainsbury's, but the competitors as well. And I've actually, so far, only managed to find 8 stores that I know have been knocked down. So this is not just closed and sold on, but actually demolished. And interestingly, the ages of those stores aren't very long. The youngest, if you like, was just 15 years old, up to 35. That gives us an average age for these stores that were demolished of 23 years. And as I say, just to sort of reiterate, this is not just Sainsbury's, this is all the supermarkets. So, what do we do with that? Well, what I've looked at is what difference that makes to our embodied carbon assumptions. So taking the 2 of Sainsbury's stores, there were 6 stores assessed for Sainsbury's, and I've taken the 2 that had that were the outliers, if you like. So one had an embodied carbon proportionally of just 7%, and one had embodied carbon proportionally of 40%, and the original assumption is on the far right there. And again, and the numbers there, store 1 and store 4, just relates to the order of the reports, but we see that there were different assumptions used, 60 years for one, 30 years for the other. And what I've done is I've taken a parametric approach. So rather than just saying, well, let's model it for one service life, I said, well, what are the options? If these store life cycles that we've seen from the demolition records were the case, what does that do to embodied carbon? So I've remodeled the original assumption based on the minimum, the mean, and the maximum. And what you see is that in all but one of the cases, proportionally embodied carbon has increased over the original assumption. So this is, as I've said, this is kind of important because we want to be able to base design decisions on this. And it, already we might think, well, that 60-year assessment, perhaps that's a bit optimistic if we're actually, some stores are being demolished after just 20 years or so. So where do we go from here? Well, first of all, academically, this is it needs to be made more robust. I've got a sample set of just 8 stores. Need to be able to expand that. So I need to sort of try and find a way to address the fact that as that picture sort of alludes to, some of our stores are very old, and how do we account for that when they haven't actually come to the end of their life yet, so we don't know what that service life will be. I'd like to also take into account some of the other assumptions that I mentioned. That there are more assumptions being made than just total service life. There are assumptions about how often the store is refurbished. We want to sort of make all of that more robust. But beyond that, I think it would be interesting to look at what actually drives service life in practice. We've seen that there are examples of supermarkets in the UK that have been knocked down after just 15, 16, 20 years, and I suspect that actually those buildings could, if they'd been allowed to, they could have lasted much longer purely from a durability point of view. So there must be other factors that are affecting how long those stores lasted. And those could be to do with demographics. There might have been significant shifts in the population, perhaps population growth. I suspect that competitor activity is a big factor as well. And if we can understand some of those issues better, then we might be able to better predict the life cycle of new stores, and therefore be able to model whole life carbon emissions in a more robust way. But also, just coming back to the sort of this aim of reducing embodied carbon, we've seen from the results, it's fairly intuitive. If a building doesn't last as long, then its embodied carbon proportionally is going to be more significant. In fact, in the case of store 4, the second example, it goes above 50% if that store were to only last 15 years. So that's a significant amount. And there are kind of two ways to approach that. One is you might say, well, let's try and maximise how long a store lasts. We have got stores out there that are lasting for much longer than just 35 years. What are the issues that drive that? And let's try and maximise store life. But you could flip that around and say, well, if actually if stores, a lot of stores only last just 20 years or so, then maybe there's an argument that says that we could build them in a more lightweight way, so that they are designed only to last 20 years. The image there is, as some of you may have come across this, the cardboard cathedral that was built in, I think it was Christchurch, in New Zealand after the earthquake. And this is a building that was designed with a 20-year lifespan in mind, and therefore they could make it out of much lighter materials which had an inherently lower embodied carbon. And maybe there's an argument to say that supermarkets could be built in that way, so that they're almost more temporary. Equally, it might just be about making them more flexible and being able to design them so that they're more adaptable for future use. So there's lots of issues coming out of this, lots of questions for the business to understand, and hopefully, kind of the point I want to get across is just how the academic piece and the business interest work really well together, and hopefully there'll be some interesting results, and for Sainsbury's the challenge is to understand how we bring this into business decision making when investment decisions are being made. How do we factor this in? And I'll leave it there. I'd be interested to hear your questions and take it further in the discussion. Thank you.
Stephen, again, fantastic.